This is another example of a bubble sort, but in this case we are sorting parallel arrays. So the example here is we have 10 cities and their populations in millions. So Chicago, for example, has 2.7 million people, Detroit 0.67, and so on. New York is going to be the highest at 8.1. Let's see, we have Miami and Cleveland are kind of on the low side, but in any case, I have carefully populated these city names with their respective populations. Okay, I was very careful to get Chicago's number with the Chicago element, and then Detroit with Detroit, New York with New York, and so on. Again, you have to be mindful when populating parallel arrays. The compiler is not going to know that this data item is in the wrong place with the wrong city. Okay, so the arrays are populated, and really, you know, the bubble sort is the same with one key change here. When we're swapping, you have got to swap both arrays. Think about that. If you're swapping Chicago and Detroit, for example, you've got to swap their populations as well. Otherwise, if you make even just one swap in one array without swapping the corresponding array, your data is garbage. Your data is garbage because now the correct city is no longer with the correct population. Okay, so that's really the main difference between this program and the one that we looked at with the gelato. So again, we start with a meta swap. Okay, that's a flag variable. As long as we're making swaps, we're not necessarily sorted. As soon as we get through one pass, a complete pass through the arrays, I should say plural, because there are two of them. We get through a complete pass without making any swaps, we know we're in order. So in this case, we're putting these cities in order according to, I believe, the highest population. So New York is going to end up at the top of the list after these are sorted. So we have made a swap. We have the temp. Okay, oh, this is interesting because I said when we're swapping, we have to make sure we swap both arrays. We need, and because we have the cities are string data, obviously, and the populations in millions are float. Those are float values. So when we're swapping and we create our temporary variables, we need two variables. They're different data types here. So we have temp city, which is a string, and temp pop, which is a float value. Okay, so those are our temporary variables for our shifting of the values when we're swapping. Okay, and so we have our nested looping technique here with the for loop inside of a do loop. Give a little space there. Okay. Going to keep doing this while meta swap equals true. As I said, as long as we keep swapping, as long as we're still getting swaps, we've got to keep going because we don't know that we're in order or not. Okay, so we start with setting meta swap to false. Do not forget that line if you're doing this in an assignment. Okay, that's easy to forget. And then our for loop, remember, you're not going all the way to the end. The for loop is kind of the nuts and bolts of the mechanism. It's comparing the element to the one after it, swapping if necessary. And, you know, again, when you get to the end, you get to that last element, there is no one after it to compare it to. So you don't want to go there. You're going to walk right off the edge of your array and your program's going to blow up. So that's why we only go to size of the array -1. Okay, whatever that size is. So now, looking at the current element at hand, I'm using loop counter j, comparing it to the one after it, which is j plus 1, just offsetting by 1. If it's less than, that means they're out of order because we're sorting from highest to lowest. So if it's less than, they're out of order. We're going to swap them. So I'm looking at the pop in millions. That's the array in question. We're not alphabetizing cities. We're sorting by population in millions. Highest at the top. So New York is going to be at the top. Probably Cleveland or one of these other ones is going to be at the bottom. So, so if they're out of order, we're swapping the populations because they're out of order. But then very importantly, we're also swapping the city names. I've got two arrays, two parallel arrays, got to have two sets of swaps. Okay, if we had 3 parallel arrays, we would have 3 sets of swaps. If we had 4 parallel arrays, we would have 4 sets of swaps. You get the idea. Okay, so we're swapping our populations in our cities. Made a swap equals true because I just swapped, and so we're not done yet necessarily. So, and then the whole thing begins again. So there it is. At the end, now the bubble sort is done and we're ready to print out the results. I just put like I'm using set W here to line things up in columns because we have parallel arrays. That'll look nice. And I have the column headers and then a quick little loop to print from the parallel arrays, which are now sorted. Going to have the city name first and then the population. Let's go ahead and run it. Okay, and there you have it. Our data is sorted according to population with the highest population first and the lowest at the last.